Okay, so welcome everyone. We are really excited to have everyone. We have a pretty large amount of audience that joined this webinar, which we are very excited about. As a way of introduction, my name is Zohar, and I'm the co-founder and CEO of Port. And I'm privileged to have Aiden and Matan. Aiden is leading our sales engineering, and Matan is leading our product, to join to this webinar and to talk about agentic engineering and how we can give context and guardrails to let agents be really creative. Most of the webinar is going to be very conversational, very product and tech driven. We are going to start with a high-level introduction to the problem space and how platform engineering teams are already starting to infuse AI into their workflows, and what are the challenges they are facing, and how you can bring AI to your SDLC without losing control, that Aiden and Matan will take us through. So to understand, like, platform engineering began to solve the engineering chaos, where you had many different tools. The number of tools increased, and the number of stakeholders and the number of teams that are involved in the lifecycle of development grew exponentially, and it became very hard for the different teams to be really self-sufficient. So when developers want to create a cloud resource, or they want to deploy something to production, or security teams want to remediate vulnerabilities, it involves interacting with many different tools, opening tickets, tribal knowledge, stale documentation. And this is why platform engineering was born. It was born to eliminate the chaos and to put things under control. But what we right now see in the industry, when we talk with many platform engineering teams today, we see that platform engineering teams are now required to infuse AI into the lifecycle of development. And it made the chaos, the engineering chaos that platform engineering solved, much bigger, exponentially bigger, because you have all those agents. They are running in the wild. They are connected via MCP to all the kind of different tools, and they take actions and make decisions. And many times, platform engineering teams are telling us that it's very hard to gain visibility and to gain human control. Often those agents make bad decisions because they rely on scattered data that is spread across the infrastructure and the different tools. And there are no guardrails to those agents. While we want to let them be autonomous and we want to let them fix issues or taking care of tickets or to help us with security, they often make the wrong decisions, and they deviate from the common sense that we like them to have. So we see many platform engineering teams are trying to bring AI to their workflows, and it's usually gathered around a couple of repetitive use cases that we see. And during this webinar, we are going to demonstrate two of the agentic workflows that platform engineering teams are building. So the first one that we are going to demonstrate is the autonomous ticket resolution. This is an agentic workflows being implemented by many platform engineering teams, where we want to take tickets created in Jira or in Linear and creating a process where those tickets are being addressed from PRD creation to technical spec creation to coding to deployment, all the way to production in an agentic way, and making sure that we bring the teams where it matters. So we are going to speak about this use case. And the second use case that we will demonstrate is how can we create a world where incidents are being resolved much quicker, almost self-healing themselves, which is another use case that we see a lot across our customers and across the industry. There are other use cases like being able to auto-fix pipelines and reduce the amount of issues developers have when their CI/CD pipelines fail, and to create a process where they auto-fix themselves. Or maybe we want to focus on specific area in the incident management and to produce an AI-generated RCA. Another use case that we see a lot is where managers would like to perform a wide migration or an initiative like moving all the Node.js microservices from Node.js X to Node.js Y. How can we task agents to do this and not the developers necessarily? that eliminates the time it takes to run an initiative from weeks to a couple of days. So we see the platform engineering teams are right now the pioneers to move the developers and the engineering from manual engineering to agentic engineering. And today we are going to discuss how can you build it in a production grade way, how do you do it responsibly, and how you as platform engineers can really control the process and make sure that you enable the technical teams to really work with agents, to collaborate with agents. While we are going through the webinar, feel free to drop questions in the chat, and we can all address them during the webinar. I'll let Aiden introduce himself, and we can get right into the weeds, showing you what it's all about.
Thanks, Zohar. And yeah, my name is Aiden O'Connor. I've been at Port for nearly 2 years. I lead solution engineering in the Americas on behalf of Port. And what I'm excited to show you today is something that after nearly 2 years of working with enterprise and mid-market customers at Port, something that can take what our customers have built in their internal developer portal and allow it to evolve. So I'm going to share my screen, and what I want to show you first is feature to production. What we find when we speak with our prospects and our customers is that they have a large backlog. It is many Jira tickets that can have quality of life improvements for their customers, their developers. But it takes a long time to go address these, and their intent, and as I can see from the responses in the poll, their intent is similar to yours. They are planning on adding AI across the SDLC, and they would like to, but they're in the planning and evaluation stage, very few in production. And so what we want to do is show you today 2 examples of how you can use Port to do just that. So taking you through the flow, you'll see today, we begin with a Jira ticket. We send that Jira ticket in with a product planning agent that creates a PRD and sends it off to the tech planning agent. Throughout this whole cycle that I'll show, you have the right context being given to developers, two agents from the context lake you have in Port, with the right guardrails to proceed to the next step with harmonious engagement between developer and agent. So after that product planning, the PRD is produced, you move on to the tech planning stage, where another agent takes over with the right context, the right guardrails. And then when a human says that it moves on to the coding stage. You use something like a GitHub Copilot, perhaps, that can write the code for this. From there, again, after developer engagement, you send this to the security agent, who can ensure that this is a secure offering in your product. And then move on to the review stage, where another agent takes over. A developer is involved to make sure that everything looks good, looks according to the needs. And then we move on to the deployment, where a final agent can go and help to deploy only upon the involvement of a developer. So what I want to do is I want to show you a couple. Please.
Yeah, maybe just to add to the review phase, what we also see a lot during this part is assessing the risk of new releases. So often many teams take a lot of time to assess the releases before they go live, because they want to understand what would be the impact and making it in a responsible way with Canary or applying a feature flag. So we also see a very popular use case where platform engineering teams are bringing agents to assess the risk, and the technical teams can view and save a lot of time by assessing the risk themselves. So the review part is also expanding to risk management, and bringing AI to the risk management is a very strong use case that we see as well.
That's a great point, Zohar, and having all of that context in your context lake that can assess risk past just the code, the feature, the way you will deploy it, and take into account business context that you can reflect in your internal developer portal in your context lake is a very important part of this process. What we want to do is allow agents and humans to collaborate harmoniously, effectively, so that you can maximize use of these agents. So we'll take a look at a couple examples today. We have some raw feature requests, and what you could see is that we have these feature requests pulled from Jira that have the right context pulled from your context lake. And an AI agent has already begun by assessing its confidence that it can perform this task with minimal human involvement. So both of these are high levels of AI confidence. So what we could do as a developer is we can maintain that touch point with the agents, and we can select an option. We can delegate this to a human, but what we want to do is maximize the return on investment that we spend on these agents. And so what we can do is we can trigger the autonomous ticket resolution workflow. No inputs needed in this example. Everything in port that you're seeing is fully customizable. And we'll just say, send it off to that agentic workflow. Now, while this one
And
works its
Aiden,
way, yeah, please.
Aiden, can you double click on like why do we need the AI confidence score, and when should we delegate it to humans, or when do we want AI to take the ticket and address it? Like what would be, the criterias for that?
Yeah, well, that would be pulled, I think, from the business context that's within your internal developer portal. So this particular feature request, a GraphQL API for your mobile app, maybe this is an experimental service where you're okay accepting some risk of an agent writing this and deploying it on your behalf. But perhaps you have production level systems, tier one critical systems that your developers pay close attention to and that are critical to your customers. So perhaps we wouldn't want the AI agent to write this code from the beginning and deploy it on its own.
Yeah.
So in this case, we'll say adding a passwordless login system for the right reason with the right context. The developer has decided that the agentic workflow should be kicked off for this. So if we dive into this particular ticket, we see all of the right context for the agent to be able to perform what it needs, and for the developer to trust what the agent does. So again, you have feature details, who owns this, who's the assigned product manager, those kinds of things. But obviously, we've kicked this off into the product planning phase. And so here we could see, again, the right context pulled from your context lake given to the agent. And we can actually go take a look at this product planning agent, where we see that this product planning agent is given a certain amount of available context. This is important. It is your context. It's more than just the information in the ticket and the code for the individual service that will be changed. You're taking into account other Jira issues, the environment to which it's going to be deployed, the service, the business criticality of that. So what we're doing here is we're passing the right context. It's not too much so that you run up costs of your agents and burn too many tokens, but it's not so little that the agent is going to do something harmful or destructive in your environment. The right amount of context pulled from your context lake.
I think this is a great point about the amount of data that you want to feed the agents. So what we learned is that often you want to give just the right data to the agent, not just from a governance perspective and like access control perspective, but you also want to make sure that the agent does not get confused and with loads and loads of data. So by narrowing down the scope of what data each agent see, effectively you boost the performance of the agents and they can complete the job much, much better.
Yeah, exactly. We want to pay attention to the costs, the risk, and we don't want to add too much to the agent for sure. So
And
that's the
then
context. Please, Matan,
I
go
would
ahead.
just call
Yeah.
out here that we show, in this case, we show Port AI agents, which are one of our new features. But Context Lake, an agentic platform, doesn't mean you have to use Port AI agents. Port AI agents are optimized to query the Context Lake, but Port also allows to connect external AI agents, N8N workflows. So think of the agent here just of an interface to the context lake, but as anything here in Port, we are API based, API first and MCP first. So everything you see can also be copied and be used with other agents like Cloud Code, like N8N, still providing the same auditability and extensibility to your context lake.
Yeah, it's a great point, Matan. People have their own agents, and as we can see from the poll, they've likely started developing them. So we want to let them maximize those agents. So adding to this, we give the right tools to this agent. Again, we don't want the agent to go perform something destructive or something that we don't want it to. So we give simply to this agent the tool that says you're able to go and generate a PRD for this feature. We can give it a prompt, and I could show additional information here. We give a description to the agent, additional contextual information, but we send the agent off to go do what it does best, given the right context and guardrails. And the output of what this agent gives us with that context and those guardrails is a PRD, product requirements document. So again, this is the format that we expect that we have as a standard in our organization. It is produced with content that has the right context. And obviously, as we could see, the only thing this agent has done is produce this PRD. So this is where the PM comes in. The PM or the developer, they take a look, they ensure that this is up to standard. But we know when working with AI agents that it may not be. So the PM, the developer, have additional options. They have self-service actions where they could say, well, I'm going to add a little bit of context to this. I don't think the agent quite captured everything that needed to be captured. So you can add additional context, and it goes and allows the agent to iterate. So here we see again the role of the developer, of the PM, of the SRE, et cetera, changing from those who write the code, write the PRD, to those who approve and decline and iterate. We see a couple other options, the option to iterate, to give instructions. These are all examples. You can build what you'd like in port. And then we see other user actions. You can decline this. You can manually update this PRD if there's something perhaps you've iterated a couple times. You'd like to take the human ownership of this. Or you could say approve and proceed to the next step. Yes, I would like to proceed. And then again, we pass the right context and we provide the right guardrails to the next agent, the tech planning agent. And they produce a tech document spec, what must be changed, what must be checked, things like this. And again, at every step in this process, we see the result of the agent. This tech document specification, the impacted service, and then the options for the developers, for the PMs, for the engineering team lead to go and proceed to the next step or not. And so we get to the end of this, and I'm going to call out the ability to review what Zohar called out earlier. So we have the ability to go and review what the agent has put together. You have a PR. Things have changed. We've adhered to this, the PRD that was produced at the beginning. We're ensuring that this is secure, that it doesn't have undue effects on the rest of our ecosystem. And then the blast radius, impact level. Zohar, please.
Yeah, no, on the review part, where we live in a world where you have code that is being generated in a very high volume, you need to find a way to do review in a more scaled way. So the way that we see that the review process is going to evolve for engineering is not only to review on the code level, but also to review on the architecture level. So if Aiden, if you can click on the review document, you can see that it's indicating in simple words what are the software components that are being impacted, and what are the API endpoints, what are the services, what are the security fixes that it applied. So it's not a review on a code level, but rather on a wider, a more business level review of your architecture, and less on the code level itself, where you usually would do with GitHub or GitLab to review the code. So also, platform engineering teams are now kind of thinking how they can enable the developers to perform review in a more scale way, where you have a lot of code changes going through every day.
Yeah, it's a good call out. It's more than just the code review. It's also the architecture review. So in this process, I've shown you the ability to integrate AI agents deeply within your SDLC with the right context from your context lake that I'll show in the next part of the demonstration, the right guardrails that I'll also show, and then allow for a harmonious, effective human to agent collaboration. And so this has been the feature to production workflow that we're showing, but obviously you may have incidents from time to time. And so I want to show you that and how you can integrate AI agents effectively as well. And so we'll take a look at this. You have, I imagine, your own incident processes where you get an alert and a developer steps in to triage. And once they've triaged, they go and they respond. They attempt to fix, perhaps they'll roll back. Again, all of this manually taking a lot of time. They may investigate the root cause of the issue and then go and remediate it, resolve it after some manual, again, communications with the rest of the team, and then conduct a postmortem. But the value we want to show you today is that with those incidents that come in, you can also use AI agents effectively throughout your SDLC, specifically in the incident management process. So instead, you could have autonomous incident resolution. You have an agent that helps you to triage and a developer that accepts or declines the triage. And we have a response and an investigation or remediation, all guided by agents with the right context and the right guardrails, and the ability for developers to step in and approve or decline, add context, or iterate in between each step. And what we finish with is a resolved incident, near zero MTTR. If you're measuring that today, it may be long, or maybe, as we've seen with some customers, you're just measuring MTTM, mean time to mitigate. So with this, you could bring that down to zero or near zero. You have agents deeply involved in the process, and the result is a postmortem that helps you to build this architecture back even better. So similar to what we've shown before, we're going to take a look at a couple of incidents that have come in. Again, we have the AI confidence assessment. We've got the incident description here. And so we can pick one of these. And again, we can either delegate to a human or trigger our self-healing incidents workflow. And what I'll show you now is one that is already in progress. We have elevated API errors. Similar to what you've seen before, we have the right context, who works on this, where these errors are coming from, what services are effective, the business impact, which is important. You take into account more than just your code base, but what is the business impact of this? How many customers? What is the blast radius? What is the live feed pulled actively from the tools we've invested in? So once we've sent this into the triage step, we can take a look at that agent. This triage agent has taken the right context from port, from your context lake that we could see here. You're able to view this and only this. We don't want to confuse the agent. We want to give it the right amount of context and not too much. And then we give it the available tools. So you're able to see which tools you have available. And I want to do a little bit of a deep dive on both the context and the tools here. So first, the context. Pulling from your context lake, we have all of your information from your systems in one place. These are all example systems. You can integrate your own. But what we have is your data pieced together in the right way, in the way that makes sense to you, so that these agents have the right information where otherwise they may not. All of these things have additional properties you can add. As an example, the PagerDuty incident, we have a lot of properties that we can show that can add that additional context. It's not purely the incident, it's what matters to you when responding to this incident. And then the guardrails.
Yeah, and you can think about it as a semantic layer for agents. Like you want to give the agents the semantic understanding of your engineering so they can understand your world, they can understand your systems, your APIs, your services, your customers, your products. The idea is to give to onboard agents and to give them the data that they need in order to perform the different goals that you set. So this is semantic layer on top of your existing infrastructure and your different tools.
Yeah. And then for the guardrails, once you've given the agent the right context, the semantic layer, you have the guardrails. So I'll scroll briefly through all of these. But you give agents the ability, again, with the right context, to be able to go and do something with this. Manually update this, approve and proceed. Obviously, those would be the human actions, but the agent actions might be to roll something back to a previous known good version, to start a new deployment, to change something, to update something. So all of these are available for you to give to your agents. And of course, you wouldn't give them all of this. You want to give them only the right things that keep us using AI safely. So we could step through the rest of this process, but we see that the incident agent has produced a triage summary in the way that we expect it. that takes into account more than just the incident itself, but the affected services and APIs, customers, the business impact of this incident. And then, of course, as you've seen before, the ability for developers, for SREs, to go and refine the agent output or decline or send out a response with this input or approve and proceed to the next step. I think I'm going to jump ahead. Obviously, we have many steps in between. This can all be molded to the incident management process that you currently have. And then we have the resolution, where again, once this fix has been added or deployed, you're able to go and review the success rate of this change. You can provide communications to your teams that depend on this service, and you can proceed obviously to the postmortem, where the agent does what it does best with the right context and the right guardrails. Developers can then review this postmortem, come up with the resolution steps, build it into their processes, and allow this not to happen again. And again, developers are given that final bit to be able to decline or manually update this the postmortem document. I see we have a question in the crowd. Matan or Roni, are you seeing anything in the comments?
Yeah. So let's up for a few questions. So first question for you, Aiden. Can the incident source be ServiceNow?
Yes, of course. Yeah, we can pull all of those incidents in from ServiceNow. We use the tables API for ServiceNow, and that can behave in the same way. You pull it into your context lake, you relate it with everything else that incident may affect, and you can follow the same process using ServiceNow.
Yeah, and maybe to amplify that, in the workflow that you showed, essentially each component of that workflow is replaceable. So Port orchestrate this workflow, but you can pick different agents, you can pick different triggers, and you can pick different tools. So everything is customizable and flexible to you. So second question, and I will take it, is are you using past information as part of agents onboarding? And there's an example, but to answer that, I will say that Port, part of our context lake is Port has the history. It has the history of your context lake, of what happened in the past, of how incidents got resolved. So for example, and this is something we do internally, we store our RCAs, root cause analysis of incidents inside Port. So whenever we have a new incident, our agents already get, and those who are deep, in working with AI and LLMs, know that examples and what worked before can help them get better response in the future. So given we store over time internally, how we solved incident essentially minimizes the time it takes to resolve a new incident. So for humans, it reduces time, from days or multiple hours to even less than that. But with agents, if they can quickly find and correlate something that already happened in the past, so this obviously helps tremendously in improving the process. In terms of agents onboarding, when you build your agent and you define the data sources it has and the tools it has, you start by asking it questions, and you see that it knows over time, and you have the ability to prompt it that way to rely on history. So that's for this. Aiden, another one. So I see a question on how we're using it in a production environment. So I will answer this. I assume that the answer is I'm not sure like exactly what it refers to, like if it's ours or your environment, but what Aiden showed in the demo, this is a demo environment we have. And when you work with Port, you can work with several environments and you have better testing capabilities. So Aiden, you might want to expand on how you manage environments and how you take it from ideation conception to a production workflow.
Yeah, we know at Port that all of your environments are important to test in. So obviously you should do this in a production environment. That is where I think you'll get the most value from an agentic engineering platform in these types of use cases. But obviously you need to make sure that this works for you. Port is very customizable. So what we always recommend is for our customers to maintain multiple environments of Port that are built and reflected in infrastructure as code. so that you can go and test this in the lower environment to ensure that this works. It works for you. Your developers enjoy it, and that it is changing their lives for the better. And then, yes, I would use this in a production environment.
Amazing. I will share before we answer more question, and we will obviously add the link, but you can see our docs. So in our technical documentation guide, you have our AI interfaces section. So here you can learn about all our different features like our MCP servers, AI agents, and Port AI, which is a component of the agentic workflows. So you can learn more here. And if you go to our guides and choose AI, and again, we'll post the links in the chat, then you'll see all kind of guides and ideas for workflows. So one way to get started is just explore the guides and see what makes sense for you. For example, maybe security vulnerabilities remediation is something you want to start with. Maybe simple agents, maybe platform engineering requests. So all kind of ideas. We add new guides and ideas here every 2 or 3 days. Again, this is just an example showing a workflow on security remediation. All of this is production ready, copy paste, so you can implement it today. So this is something we'll share in the chat. Yes, I'm just looking if we have any more questions.
I see that there is a question about is Port currently using in their production environment? So the answer is yes. We are using Port for autonomous ticket resolution with a router agent that decides what goes to the teams and what goes to agents. We were able to eliminate the time it takes for specific bugs and specific features from weeks to practically couple of days. And we are also implementing a Port as part of the generation of root cause analysis report to help our on-call engineers investigate and triage the incidents much faster. Across our customers, we already see our customers are leveraging Port to create those agentic workflows, and this is running in production for companies with thousands and tens of thousands of engineers and companies with hundreds of engineers. So this is already running in production both for Port and for Port's customers. I would also mention that for those of you who are using NA10 as a workflow engine, we play very well with NA10. So you can use NA10 for creating the workflows, and you can give the agents inside NA10 the access to the context lake where they can consume data and take actions, and creating the human to agent collaboration with Port. So if you're using NA10 for our workflows for engineering, this is playing very nicely with Port, and we are also going to do a few community sessions about the collaboration with NA10. Great. So before we conclude, and I see that there is another question. Where are you testing AI for auto remediation of security vulnerabilities?
Yeah,
Matan?
so actually something we started last week is that, and internally in our company, is that whenever we apply AI agents or some kind of agentic workflow, we also rely on Port and Port agents for the feedback mechanism. So I will answer on the pull request review, but the same goes for security vulnerabilities. So when we have a pull request, we deploy different coding agents to review it. And then we provide our developers with a quick command from the pull request to say review, and then they could type, the PR was pretty good, but I think it left unnecessary comments. Then Port AI agents aggregate it over time, put a sentiment, and our platform team has a dashboard showing the feedback per different coding agents. And this is how they can kind of decide which coding agents to apply at the end. Similarly, you could apply the same process for security vulnerabilities. You find, you deploy a fix, and in terms of how to get started, I would even say here that you should start with humans in the loop. You shouldn't assume agents doing all perfectly. So I would start by picking the automation, letting the AI fix it, but stop at the pull request level. And then in the pull request level, I can add the feedback mechanism. And then this is one way I could test it. I could see what is the feedback from developers, from engineers, from security teams, how different models or agents might behave. So this is another workflow and guide we will publish soon. So this is how to test it. And I will extend on how to get started. And going back to what Aiden showed, the way to get started is figuring out what you have today already that makes sense to have in a context lake. And once you have that, connect it to AI agents. It could be port AI agents, it could be MCP server working from kind of an agentic IDE or one of the foundation models or some other framework you work with. But this would be a start, like connecting the AI piece with the context lake. The second piece would be how I can extend it for more agentic and autonomous workflows. And as always with AI, our take is start small. Like even if you're able to assign the right reviewer to a PR or send a Slack message for the team owner once there's a new incident, or analyzes when there's a failed build based on historical failed builds, what would be the remediation step, and send it to the right person at the right time. Yes, it might not be the fully capable, agentic AI that drives everything from 0 to 10, but we go there step by step, and you gain trust in AI by working step by step, seeing the value of the context lake, seeing the performance and feedback, and going on to the next step. So this is more widely on how to get started. Aiden, this one is for you. What other guardrails can you demo, other pointing to specific actions that you already showed? Or in other words, when you look at these agentic workflows, what other types of access controls, guardrails, controls you have into what those agents can or can't do?
Yeah, it's a great question. I think besides self-service actions and automations that can be kicked off, I think role-based access control, and that needs to be there needs to be dynamic approvals involved as well. As an example, if you have the ability to read certain entities, you want to give that maybe only to certain agents based on some criteria. Running actions as well. I mean, if a developer is running one of these workflows and they decide to send something to an AI agent that can do perhaps something destructive, we want to ensure that the role-based access control can evaluate, is the service production, is the business impact above a certain threshold, are there major changes to the open source packages involved? So we'd want to evaluate that using the role-based access control that's deeply ingrained in port. Matan or Zohar, anything else to add with that?
I think it's also an interesting discussion to have, like, are AI agents are there, like, is it or a he or a she? Like, is it a new entity we have in our kind of organization? Do they need their own user role, their own, service account? So this is something we are tackling with, like, this is something we are considering and thinking of. As of today, when you work with port AI agents, and generally when you connect to a remote MCP, you need to provide the kind of the access token or kind of the credentials of someone, a person. So when I connect to port, I connect from a people perspective, specific person that has specific permissions, and the AI agent as well as the MCP can't do something that you won't be able to do from our UI or from our API. So that's the major access controls and guardrails layer. But an interesting discussion to have is if I want an agent to auto-remediate a security vulnerability or merge a PR in some cases, it might not do it on behalf of a person. It might do it on behalf of a team or a specific workflow. And this is where we're going. We're going to a place where agents will just be more kind of entities, kind of a new user kind of type in your catalog, in your software system. So this is something we are considering. Either way, without or with it, you can decide what kind of data the agent can access, what kind of tools it can run, and even to an extent, in what cases. For example, we have internally a case where on-call persons can have more access than other. So if I'm on call, I have access to read certain data from our Kafka clusters or from our SQS. And similarly, if I'm using the MCP or an AI agent, if I'm on call, it will have more access than if I'm not on call. So even the same AI agent with the same action and same data and same workflow could have dynamic access to data and actions. So all of this eventually, comes up to creating a very robust and flexible permission system and guardrails.
So we have two additional questions left. The first one, we have someone starting to experiment with Port for agentic workflows. Their current blueprint is much simpler than what we've shown today. They're asking for any tips we have for companies that are just starting out designing their workflows regarding what works and what doesn't. This person is very interested in failure states and retries. So I'll take a first crack, and then Matan, I can pass it to you. I would say I wouldn't worry about the simplicity for right now. I would definitely be testing this in a lower environment. I would iterate this quickly. I would make sure that test in some cases that what the intended outcome should be, and then adjust based on that, and then give it more complex prompts and incidents or what have you with what you're testing. So start in a low environment. Don't worry about the simplicity. Add on piecemeal as needed, iterate, and then promote to production. Matan, anything for you or Zohar?
Yeah, I would also say that what works really well for our customers is not to give full autonomy to the agents right away, but rather put more manual approvals and start with granular manual work that engineering are doing today. For example, creating an RCA report or creating a PRD. It does not have to go all the way to all the autonomous ticket resolution end to end. So choose more granular manual tasks that you can orchestrate, and then start to expand towards the entire from code to production manner, or if it's an incident, before it completely self-heal itself, you can start with granular specific manual work that can assist engineering and apply at the beginning more human intervention and visibility to the teams to collaborate with AI. So bottom line is start small, and as Aiden said, be risk aware and apply the test, put it in the test environment, and then go to production. One more thing that we see that is working really well is to make sure that you have visibility to the success rate of the agents. So teams are building dashboards inside Port to see what is the success rate of the agents for specific jobs. Does it apply to the KPI that they've set to themselves as a target? And if they see that the agents are not performing as well, for example, you can measure the PR merge rate, like what is the PR approval rate for AI generated code that goes through the workflow, and put yourself a KPI or a target to improve this rate. So this way you can deterministically know if AI is doing a good enough job for you, and you can really measure its success over time. And what we often see is once you create this workflow and bring the context to the agents and making sure that humans can collaborate with the agents, all the metrics going up because you applied the right change management, you gave the agents good context, you've set the right guardrails so the trust remains high, and those kind of things you would like to keep track of and creating a dashboard for.
Yeah, the only point I would add is that from a product perspective, we are building our next-gen workflows. So more tactical requirements around failure states, retries, fallbacks. This is definitely feedback we'd like to get. And everyone who wants to join our closed beta can definitely let us know and contact us through our support channels or through our customer communications. So that's the only point on that. I will also take the next question. Can you combine the context available in Port with additional context available to our own AI agent? So I will answer it from two directions. Either you want Port AI agents to have context that you have internally. Maybe you built an AI agent, maybe an MCP server, and you want to connect it to Port. or the other way around. You have an AI agent and you want it, in some cases, have access to the context lake. So both are available. Let me share my screen for a second. So what you see here is an AI workflow with several AI agents we have in an NA10. This is a workflow we have around releasing new features that handles the communications, the announcements, and the change logs of it. And you can see this part, which will become a dedicated port node in the future. This part is essentially communicating with port context lake. What you see here is that a pain we had is that once a PR was merged or deployed, we needed to know who the owner is, and what the task is, and what service it's related to. And this thing we bring, and all of this we kind of bring from port. We can do it with either with our AI agents or directly with port MCP servers and APIs. So even here in this AI workflow, I rely on port context. That's on your AI agent working with port. If you go to our API reference under AI, you'll see that you can interact with our AI agents via API. So it's not an A2A communication or something like that, but it's a REST API, streamable, available with everything you need. So you can try it out and see what it brings you. So this kind of connecting your AI agents to port context lake, and I can show we already have customers who are doing exactly this, build their own infrastructure. The other way around will be supported very soon. What we're working on is the ability to connect external MCP servers. So imagine that some aspects of data in your software catalog or in your software development lifecycle doesn't necessarily belong to a catalog or to a context lake. For example, logs, metrics, detailed code. Like your code is part of your SDLC, but it's not something you'll manage in your software management tool, right? In that case, you'll be able to connect GitHub MCP or Notion MCP or Confluence MCP to bring those additional contexts. So imagine I'm connecting Sentry MCP or Datadog to bring metrics or logs just in time when I need to analyze an incident issue. So these will be available very soon. And what we're also exploring, and feel free to contact us and we're happy to work with you on that, is the ability to connect MCP servers that you've built internally. So not necessarily the ones that major companies expose, but the one that your company created for your internal services and internal data, but you don't have the bandwidth capacity, and this is not the product you're building to take all of this and expose it in a great AI interface. So all this is coming on our near roadmap, and we're happy to collaborate with customers and prospects on this.
Yeah, I wish we had more time for questions, but we're nearly at time here. So what I want to do is pull up the final bit. For our customers, don't hesitate to get in touch with your rep or jump into our community to ask questions and learn more. For anyone new to Port, we invite you to see it in action through a more detailed demo. Roni's going to drop the link in the chat to ensure that you know how to do that. And we really thank you all for your time and attention today. These questions have been great. Hopefully we speak to you again soon. Big thank you to Zohar and to Matan for leading this session with me. And we hope to see you all soon. Thank you.
You guys.